In the past few lessons, we discussed methods for enforcing business policies, specifically declarative calculation of property values and automated decision logic. Declarative rules evaluate automatically when a trigger value changes. We can delegate the responsibility for updating the value to PRPC. Through a mechanism known as declarative network, PRPC can identify dependent properties and trace the dependency back to their source. And through another mechanism, known as forward chaining, PRPC can automatically push changes to a source value all the way through the declarative network to any dependent properties. All of this happens automatically, freeing us from the need to anticipate changes and update values manually. We explored these concepts with the declare expressions rule. Declare expressions set the value of a target property according to a specific formula. We can add, subtract, multiply, and divide combinations of property values to model any calculations. We can even use declare expressions to evaluate other rules, such as decision tables and decision trees, as part of our expression. We can also use declarative rules to validate property values, update database records, and perform other actions. Although these capabilities are more sophisticated and best left to more advanced users, in some cases, senior system architects, or SSAs, and lead system architects, or LSAs, the principles behind them are the same as those for declare expressions. We also explored rules that allow PRPC to make decisions on behalf of users. Rather than creating assignments for end users to evaluate data and choose the appropriate response, we can model the decision logic with PRPC rules, when rules, decision tables, and decision trees. When rules allow PRPC to answer Boolean-style questions, questions that require a yes-no, true-false, or on-off response. We used a when rule to skip a portion of our candidate process under specific circumstances. We can also use when rules to direct cases through a process flow, and even enable and disable options within our UI. We also learned about decision tables and decision trees. These rules allow us to assemble combinations of conditions to test, either in a grid or a branching structure, and allow us to designate values to return for each combination of conditions. Decision tables and decision trees allow us to model more complex decisions, such as if a vehicle is leased and garaged in a particular location and the driver does not have an insurance policy with a satisfactory level of coverage for damage to other people's property, then they must increase the coverage on their insurance policy. We use decision tables and trees in process flows to direct cases to specific assignments. We can also use decision tables and trees to determine case routing. The two-decision table and two-decision tree routers allow us to use decision rules to route assignments. Unlike the other rules we've covered in this course, properties, UI rules, and flows, policy rules allow us to model policy logic in our solution. By doing so, we can automate policy enforcement, allowing business users to process cases more quickly and consistently than if these policies were enforced manually. Policies are the most reactive elements of our solution, as they need to adapt to changing business conditions, often with little or no warning. As a result, we want the business to remain engaged in the maintenance of policy rules. One way to do this is through delegation. We can delegate these rules to end users, generally line managers, allowing them to update the policy logic in response to changes in business conditions, rather than wait for an updated solution to be developed, tested, and released. This is just one of the ways in which Pega solutions allow us to build for change. Delegation should be performed by SSAs and LSAs, and rules should only be delegated to a small, approved group of trusted users.